Good afternoon, everyone. My name is Michael French. I'm an associate professor here at Stony Brook University in SoMAS. And today I'm going to give you a brief tour of our radar facilities, our weather radar facilities, and talk a little bit about a few instruments. So here I am where most of our instruments are housed on campus. And the motivation for all of this, for this radar science initiative that's being led by Professor Pavlos Kolias, is that there's a few radar hubs across the United States. One is in Norman, Oklahoma. There's another one in Boulder, Colorado, one in Huntsville, Alabama. And there wasn't one in this part of the country. And so we have instruments here that are set up to focus in on problems that are unique to this area. So I can walk you through a few of the instruments here. Really, I think maybe the crown jewel I'll start with. This is Casper. This is a scanning radar. It's a cloud and precipitation radar. It operates at Ka bands. And so it's a high frequency system, and it can get really, really fine detail of what's happening in the lower cloud level and with both clouds and precipitation. It also has dual polarization capabilities. That means that it can provide us some additional information about the type of hydrometeors that the radar is seeing. So it can provide us some estimates of raindrops or snowflakes, size and shape, liquid water content, heterogeneity within a volume, so if there's mixed precipitation. Really, really, really valuable information if, for example, you're scanning in a winter storm, which is what the focus of this radar system is. Out of these types of systems across the country and even the world, this is certainly near the top, and it probably the most advanced version of this type of radar. So this is Casper, and it can be operated remotely, in fact, or from this room you see here. We also have Roger. This is another even higher frequency radar system. And this, operates at W band. And this is for vertical profiling. So we can get an idea vertically right above us what's happening, again, with a lot of spatial detail. So you might imagine if you were collecting all of this unique radar data during a snowstorm, wouldn't it be nice to have some ground truth, some additional information about what we were actually seeing at the ground during, say, a snowstorm? And we have a number of instruments to do just that. So this, for example, is a distrometer. The distrometer provides us information about how fast precipitation is falling, what type it is, and even some estimates of how large the precipitation is, the diameter of the particles that are falling. And you can see next to it, we have a camera here. And this camera also provides us information about the hydrometeors, the types of precipitation we're seeing. And you can imagine you can get views from a number of different angles. And again, that gives you some information about what type of particles you're seeing and what their approximate dimensions are. And another version of that same idea is here we have rigged together this conveyor belt. And so what happens is during a snowstorm, this conveyor belt would be on, and particles would be falling on it, snowflakes, for example. And then as it makes its way through the contraption here, it has photos taken of the various particles. So we can get an idea of not just what type of particles we're seeing at a given time, but how they're changing in time. At the very other end of this enclosure, you can see a LiDAR. And a LiDAR is really good for capturing information about the atmosphere in the clear air where you don't have a lot of precipitation. And we have some other instruments here as well. But this gives you a sense of the type of radar information and data that we're able to collect, combined with all the individual tools. We can do some really unique research on winter storms and other types of phenomena that are really unique to this part of the country. The final topic I'll address today is opportunities for students. So you'll see this big crate here in the picture, and this houses a lot of supplies, including weather balloons. So it's not just us collecting data during these events. We solicit help from both undergraduate and graduate students to aid not only in collecting radar data, but also launch weather balloons and collect other types of data. So the final instrument I'll mention in that regard is, you see this big open space here. Usually we have our mobile radar, our mobile X-band radar, another high frequency radar system, and it's mounted on a flatbed truck. And the upside to having this radar system, which we call Skylar, is that you can bring the radar to whatever you're interested in instead of waiting for whatever you're interested in to come to you. So during winter storms, that might mean bringing the radar to the north or south shore of Long Island and collecting even higher quality data. If you're like me and you're interested in severe storms and tornadoes, you can bring the radar system to even other parts of the country to collect that type of information. And that's, in fact, what I'm planning on doing in the coming years, including a project we have in the Southeast US studying squall lines. As a result of this, we need folks to help. And so whether you're interested in winter weather or severe weather or not, you may want to be part of the research process. And so we're always looking for graduate students to help out in collecting data. It's a great experience. So with that, thank you for joining me on this tour of our Stony Brook radar weather facilities. And I hope to see you in the coming academic year here at Stony Brook. Thanks.